welcome to Aztec B, and thank you guys for joining us. I'm very pleased to introduce my good friend Ori Elkin from DigitalGlobe. Ori will be leading a talk titled The Big Picture, The Journey from On-Premise to Cloud to the ML Marketplace for a Geospatial Data Platform. Ori is the product lead for DigitalGlobe's commercial analytics efforts. He manages the GBDX product suite, which is DigitalGlobe's geospatial big data solution. Ori has been working on data and analytics products, which are his main passions outside of dairy farming, for the past 15 years. Without further ado, please welcome Ori.
Thanks. I got this, yeah. All right, guys, thanks for coming. The next 30 minutes or so, I'm going to walk you through some of the things happening in our world. I was told I was supposed to stay on that stage, and I'll try to remember that. I'm going to briefly walk you through some of the things happening in DigitalGlobe in our transition to the cloud, some of the challenges that we have faced, and how we're trying to mitigate that in order to bring new things to our world. So I'll start with some context on the company. Not a lot of people outside of our industry know about DigitalGlobe, and I always like to take the opportunity to explain how big and important this industry and the initiative that we're working on is. In terms of the brief history, the company has been around for more than 25 years now. Obtained the first commercial satellite operation back in 1993, like the dark ages. We launched our first satellite, and the first 1 meter resolution commercial satellite ever in 1999. And ever since, we successfully launched and launched 7 satellites operating, 5 of them, 2 have been decommissioned and are back on Earth. Over the years that we've been operating since 1999, we've collected over 110 petabytes worth of what we call archived imagery. Essentially, those are pictures taken from our satellite. I'm talking about the size of the data of imagery alone. That's the equivalent of around 8 billion square kilometer. It's 50 times over the land mass of the Earth. So we've accumulated a pretty substantial amount of data over the years. And historically speaking, the main customers for DigitalGlobe has been government entities, US government and foreign entities that wanted to use a satellite for their operation. In the past, I would say 5 to 10 years, our commercial business offering has increased substantially. And we're working on allowing innovation to happen in that space. And I'm going to walk you through some of the efforts that we are doing. So, trivia question. Any idea what this is? Don't focus on the airplane, but focus on what's happening underneath here. As amazing as this might sound, the early days, before we had digital, satellite actually went up to the sky containing rolls of films. They'd taken picture, and they were designed to dispatch them down back to Earth. So this special equipment that you see underneath here is designed and built with the intention of capturing those rolls of film mid-air. There's a plan B. Is actually, you see that's all happening over water. Those capsules down here was designed to float for a few minutes. So if plan A fails, we got plan B. Someone go with a boat and actually get the film. Why am I telling this? First, this is pretty interesting. And second, as amazing as this looks to us these days, what the process that happened from that point onwards really haven't changed for about 40 years. So let me walk you through the journey of what's happening next. Yes, there was some advancement in machine vision that allowed us not to send the films to, people eyeballs to look and investigate what's in the pictures themselves. But the process pretty much remained the same. So if someone wanted, let's say, 2 or 3 years back, if someone wanted to get satellite imagery from DigitalGlobe, or for that reason, any other company, that person would go online, search the archive of few million imagery that we've captured over time. They pick up the phone. I deliberately picked up this icon of a phone because I think it represents nicely the technology. A customer service from our end would pick up the phone and take the order. They would then place that order to what we call the factory. So we actually store this amount of data, which is pretty incredible, on tapes. And the factory would take the data off the tapes and will produce an image. Now, another important thing to remember, when the satellite takes a picture, it's about 2,000 square kilometer worth of data, which is pretty substantial. And it could be up to 35 or even 40 gigabytes for one image. So let's say you want to do an analysis of, all right, I want to count how many solar panels are on rooftops in Colorado. That is roughly 700-800 images. So there's no easy way to send that over. So the customer service would actually load that into a FedEx envelope and ship it over. Then the customer would put that in their on-premise servers. They'll hire a bunch of PhDs that know what they're doing. They will come up with an algorithm to extract that information. They'll run it. It'll fail. They'll run it again. It will fail. They'll run it again. It will fail. And eventually, they'll succeed. So this whole process that I've described here, we're probably talking about a few weeks, not say a few months. And I pretty much presented a very simple question. How many solar panels are rooftops in Colorado? That shouldn't be that hard. So why? That's the big question we all have to ask ourselves. Why is this the way things are operated? Well, there's actually some good reason why this is operated that way. Storage costs, compute costs, data transfer costs, they're all used to be pretty substantial. There was simply no other way of doing it because of the size of the data. There was no business model. Once we shipped the pixels over to the customer, they practically owned the data. So they had to buy it from us, which, in order to recoup the pretty substantial investment we had in sending satellites to the sky, we had to charge $5, $10, $15 per square kilometer. Do the math in your head, what that translates to. My Colorado examples, we're probably talking few millions of dollars. In addition to that, there was, because of the cumbersome way this was done, there was lack of commercial grade tools of extracting that information. And the last problem is that the data is heavy, as I mentioned, 35, 40 gigabytes worth of data. That's, even to load that to a machine, that takes time. That takes a lot of I/O operation. So there's some reason why this has happened. But what the result of that was, there's lack of innovation. So the extraction tool and the algorithms that were developed over the past, I would say, 20, 30 years are either use cases that are supported by big companies that had the budget to operate and answer pretty expensive questions. And the second are things that were developed in-house in companies like ours. We developed because, honestly, we thought they were cool. There was no real market demand for the questions because of those barriers. So comes GBDX. The simplest way to think about GBDX is a set of capabilities that are all designed and built in the cloud environment that would store the data. That was premature. Store the data, host a set of algorithms to compute against the data, have a catalog that will allow end users to search it and have the ability to order more information as needed. We came up with this concept of what we call GBDX Inside, which this engine that we build is actually powering a lot of products. Some are in-house, as you can see from the logos. Some are actually from third-party partners. They build their geospatial solution engines or products on top of the underlying engine that knows how to produce the information at scale in the cloud. Okay, so how are we doing this? I'm going to start addressing the questions or the issues I've identified in the previous slide. So the first one was compute and storage cost. So this is me bragging on my Excel skills. For whatever reason, there's no lack of public information about historical prices on AWS or any of the other clouds. So I kind of went through the AWS blog announcement on price reduction. And as you can see, Mr. Moore is actually helping us in kind of our journey to move everything to the cloud. So this is the storage cost, as you can see, from like around 2010 till today. The price dropped from like 15 cents to 2.5 or something like that. And on the compute side, prices dropped 4x from around 80 cents to 18, give or take, for one particular machine. So what that means when it comes to our use case, if someone wants to extract information at scale from the cloud, we're probably talking about, this is 25 times cheaper to do it than what it used to be 6, 7, 8 years ago, which is really helping. Data transfer costs. Some of you might have seen that image. AWS was all about this. So this is a picture taken from our satellite, Worldview 2, last year. This is our headquarters in Westminster, Colorado. This is me right here. And what you see here in kind of the yellow circle is what is called by Amazon the snowmobile. So Amazon actually shipped us a trailer over, which parked outside our offices for about a month and a half. And we loaded all the data into that truck, which was then rolled to Amazon headquarters and uploaded to the cloud. This is probably the only way that we could have done it, talking about hundreds of petabytes worth of data. Otherwise, you could probably send thumb drives, like a gazillion of them, over to AWS. It will break and fail and whatnot. So this really helped us in kind of moving to the cloud and working with the cloud providers in order to support our use case. I'm missing some slides here. Okay. GBDX is, I kind of mentioned before, is designed to work at scale at the cloud. Here are some of the numbers that we're seeing from our operation over the past 2 years, give or take. So this whole thing that I described, this is all still pretty new. So we've operated over 19 million hours executing algorithms in the cloud. If you know roughly how much an hour costs, you can do the math. That's pretty substantial. We have analyzed over 22 million square kilometers worth of data, and over 38 petabytes. We're having accounts or users from 56 different countries, and we have an uptime of close to 100%, which is what we aim for in commercial grade. So if I go back to my slide about the problem, there's still one issue that looms above everything, which is the lack of innovation. So how are we helping? How are we advancing this? So I'd like to kind of show you pretty briefly the latest, one of our latest offering in this space, which is there a way for me to share the browser? This is just sharing the... Wait, maybe if I... You know what? You'll pick it up. Okay, yeah. Looks like it's working. Okay, thanks. Okay. So what I'm going to do the next 10 minutes or so, give or take, walk you through our attempt to bring innovation to our space. And again, bear in mind the history of what we're talking about. So the industry that we're at was pretty secluded in terms of the availability of the imagery, just because of the price point, the lack of accessibility to the imagery, and the lack of commercial tools. So this is our attempt to bring more innovation to our field, and as much as I don't like to use the term, do some sort of an effort on the democratization of the data and make sure that the data is available and more people can do more cool things with it. So this is our solution built on top of Jupyter Notebooks, which we call, not surprisingly, the GBDX Notebooks. And I don't see it on my screen, so I'll do it over there. And I'm going to walk you through a brief use case example that we've developed. And just to kind of show you the things you can do with satellite imagery when it comes to building new capabilities. So what we have done, so I don't see it here, so I'll show it over here. So what we have done, we've integrated into the Jupyter environment, as you can see right here in the corner, three models that allow the notebooks environment to talk to our GBDX infrastructure. The first one, let me make sure that I see it correctly. So the first one is around searching for imagery. The second one is ordering, and the third one is deploying the algorithm developed back to GBDX. So I can do it from my computer, but what happens when you click on the first tab, it'll open a map of the world. You can draw a box and search for your area of interest and come up with imagery that you might want to acquire. Once you identify the images that you want to interact with, you click the order button, or you go to the order tab that you see there, and it actually talks to our factory to bring the data back into the notebooks environment. And the third is designed to wrap the process up when you're done with developing your algorithm. Bear in mind that the Jupyter environment is pretty limited in terms of the compute power. You definitely cannot run anything that is statewide in this environment just because of the size of the boxes. If you want to do it in that scale, or even a country scale, or worldwide scale, deploy that to GBDX, it'll run and generate the output for you. So let me walk you through this short example that we have built. So just ignore the first couple of this, just uploading some Python scripts. And as you can see here, what we're doing is we're calling one of our imagery. So this is Harbour in Sydney, Australia, and using a catalog ID, which we identify using the search tool. All we're doing at this point in time is defining some basic objects and presenting the harbor or the bounding box that we cut out of the image in this space. The second thing we're doing here is what we call segmentation. You might have heard they use LULC or something similar to that. Essentially, we look at the image and we say, okay, what's in the image in terms of broad areas. So what we've done here in the image on the right is simply say, okay, tell me where's water and where's something else. So as you can see, the green is the something else, the blue is water. As you can see, we map kind of all this stuff you see right here, which is kind of the docks and whatnot, and the boats in the water. You see those as green dots over here. And what this allows us to do is once we identify this allows us to say, okay, let's assume that the task that I'm trying to develop here is to essentially count or show me all the boats that are in the water, not docking or nothing on the earth itself, on the landmass itself. So as you can see, all the blue dots that we're seeing here, using machine learning, it's actually highlighting all the boats in the water, and you can see right here, all the boats that are docking are kind of being ignored because they're, the machine learning algorithm here counts them as part of the land. So this allows us to actually count how many boats are in the water without someone going to the picture, instead every picture and counting all the boats. Okay, not that fascinating so far. Let's take it a step further and say, okay, we actually have not only one image of that area in Australia, we actually have a list here of 10-ish images that we've captured over the past 5-6 years. So what this allows me to do is use some of the Jupyter tools to plot this and say, okay, show me a trend over time, how many boats in the water are in that particular port in Australia. Okay, we're seeing there's some trends, maybe it fluctuates a little bit, but nothing too significant. So how can we take that to the next level and start make this an interesting story? So the Jupyter Notebooks and the availability of online information allows us to actually start crossing that information with different data sets that are coming from a totally different sources. What we've done in this notebook example is we go to, I think it's out of the image here, but we go to an online weather information historical data, and the line that you're seeing underneath here is actually plotting the temperature measured in that particular day in the same area that we're seeing here. And now this actually is starting to make sense. Okay, not too mind-boggling, but you actually, with the naked eye, you can actually see, okay, there's some correlation between people going out on boats and the weather of that particular day. So again, this was designed just to give you a taste of what that information contained in our imagery and how that could contribute to the analysis of the data and extracting information, making meaningful decisions based on that. Let me see, I think that is the end of my slides. Okay, I can't move anything here. So I'll just stop here and take any questions if you guys have them. Yep. I think there's a microphone supposed to go around. Okay, just ask and I'll repeat the question for the benefit of the recording.
Can you guys hear me? Okay. So I think this, like the graph that's up there is an interesting example of breadth versus depth, right? Because you guys take pictures all over the world,
Yes.
but you don't necessarily take them that frequently everywhere, right? So you only have like a couple of observations over time for every single place.
Yep.
So how do you deal with that breadth versus depth in trying to formulate the questions that you guys can answer?
That's a great question, and those are kind of the slide that I'm missing. So I'll repeat that question. So the question is breadth versus depth. This is true. The capacity of our satellite, or any commercial satellite operator for that sense, is pretty limited. We tend to revisit areas of the world depending on their attractiveness, once a quarter or once a year, or some remote areas that no one is interested in, even lower capacity than that. So part of the solution of GBDX is actually aggregating all the data of commercial, free, and other data sets into GBDX. So as I mentioned, we're operating 5 satellites ourselves. In the GBDX solution, we catalog, or we ingest into our catalog data from public data sets in our world, which is, there are actually 4 satellites operated by either NASA or the European Space Agency that actually collecting data on their own, and this is publicly available, and it's available through GBDX. We're actually partnering with some of our competitors in this space to bring their data into GBDX, because what the GBDX engine is offering them is a different way to monetize their data that they don't have. We're not competing directly with them, because essentially what's happening in GBDX, all of the data is computed in the cloud. No one gets the pixel. It's not the FedEx model that I just mentioned. So it is a different way for them to monetize the same data they've collected anyway. On top of that, we have a lot of what we call vector data, which is anything that's geospatially tagged, and we can place it on the Earth. We can ingest that. Twitter is a good example, because some tweets are geotagged. So we can ingest that, and if that is needed to enrich the data in the compute process, that is there. Our industry in a whole is kind of going through a revolution over the past few years, and that's the emergence of small sats, or small satellites. So the satellites that we're operating, they're pretty big. Like it's from here to the wall. They're substantial. It takes years to build them. Companies like Planet and others are taking a very different approach, and they're building, it's pretty much like a mini fridge size satellite. And they're throwing a lot of them out there. We're talking about hundreds. They're not close to the resolution that you've seen in the image I've shown you here. But that might be useful for certain use case. Yes, the picture will look kind of blurry, but if you just want to see show me the water, that can be done with that kind of resolution. So incorporating all that into one platform is kind of our bet to make sure that no matter what the use case, we have a solution for that on GBDX. Yes?
You mentioned that you're using various public data. You mentioned you're using a bunch of public data sources and vector data,
Yep.
combining it with your satellite imagery. What platform and how are you gluing all that together to provide these insights?
Okay, good question. So the question is about combining different data sources that are geospatially in nature into GBDX, and how we're doing that. So our approach is different, as kind of shown from the slide before, is we're the engine. Whatever you do with that data, it's not really up to us. It's up to the end user. So what we've built is essentially using Docker, a containerization solution, that once a machine learning, or it doesn't have to be a machine learning algorithm, is being built, it can be deployed to GBDX, and it's up to the algorithm itself to figure out the data sources that it needs in order to operate correctly. And pretty much can do whatever they want with the different data sets that we either host or catalog or make available through GBDX. So that's kind of our approach. Our approach is we don't know, what's the next thing. We don't know what's the best thing to develop in either commercial or government or whatever environment. It's up to whoever is writing the algorithm or the task to come up with that and access the different data sets. Make sense? There was another question, I think, earlier. No.
Yeah, I'm just wondering, how far off do you think you guys are from being able to do any type of live, obviously not here, but from a vector perspective, the type of live data that you can capture to run analytics across that as it's happening?
You're talking about satellite imagery?
Yep.
Okay, so I repeat the question. What's, in my own words, what's the delay between data being captured and data being made available on GBDX, correct?
Yes, and how far off you think you are from getting to a more current state?
Yeah, so it's a great question, but this is not really the use case for GBDX. I'll answer your question, but I'll explain why we're not considering this to be the use case for GBDX. So GBDX was designed to extract data at scale, as I mentioned. Every time you look at live feed or close to a live feed, that's, in our definition, not at scale. We called it the show me there versus the show me where use case. Show me there is like, this is a classic, military operation. I need to see one particular place on Earth because I have some sort of a need to make a plan. We're looking, a GBDX context is looking as show me where. So show me where all the cars are in the US at any particular point in time. Show me all the solar panels and rooftops. Show me all the buildings across the world. We can actually answer those questions. So that's why I kind of mentioned this is not a GBDX use case. But the delay from what we call acquisition, when the satellite actually takes the picture, to when it's being made available in GBDX, it kind of varies a little bit, but it's not that substantial amount of time. So there's a few minutes that take, because it's not video, it's still image. The way the satellite operates, whenever it goes over the Earth and when there's daylight, they take a picture, and when they're kind of the dark side, they transmit it back to our ground station. So this operation usually takes 15, 20 minutes, and then there's another 20 minutes or so from the ground station to where we can actually produce the image. We've seen images in our catalog in as short as 15 minutes. It usually takes us a couple of hours to make them available. Yes, a question in front.
So aside from using the snowmobile,
Yep.
what was the biggest challenge with actually being able to get the data in a way you could get it in the snowmobile, but I'm sure you had to extract it out of
that's
large
actually
systems?
Great question. So the question is about the outside of actually getting the data to Amazon, what was the biggest challenge that we faced in terms of actually being able to show you the clip that I've shown you in the image itself, in the notebooks. So it actually was pretty hard. I would say there's three main reasons why this was hard. Let's start with the data formats. So remember, we're dealing with an industry that is probably 30, 40 years old. The actual data formats that were basically the industry standard was not optimized for the cloud, for the base. So we actually had to, so the way this works right now, every time we kind of get an image from our factory, we convert that to a format that will allow us to do what we call streaming of that data into whatever end client. So that was the first one. The second one was essentially a lack of data streaming framework, because this is such a niche problem, and no one really tackled that in the past. We essentially had to write the framework ourselves, and that took a long time. And I would say the third problem is essentially our entire industry was built about around analyzing strips. So I didn't go into that, but if you think about what's happening in satellite operation, and I apologize for the geekness up front, so when the satellite takes a picture, it's actually not looking down, it's looking sideways. So what happens is the image is not a nice rectangle, it's like I can never say that word, a parallelism or whatever you call that shape. Plus there's noise in the picture, so there are clouds, there's haze, there's atmospheric particles in the image that actually make the image look inconsistent over time. So what we have done over the past 20 years is we came up with algorithms that can actually take away that noise. And regardless of haze or we call this atmospheric noise, we can do that compensation and say, okay, we can produce an image over time that would look alike. And you don't have to deal with images that are kind of blurry or kind of the color tone is different because of the particles in the air. So converting those, what we call them ugly tasks because it's an acronym for undifferentiated geospatial heavy lifting. No one cares about that, right? I mean, this is a problem that we should deal with that, and no one should ever think about this. So, but taking all those algorithms and converting them to a way to work on tiles versus strips, because that's how they developed 10, 15 years ago, that was actually a pretty substantial effort as well. So I would say those are kind of the three main challenges that allowed us to move from what I call heavy data into a big data realm where we can actually take advantage of open source and other big data solutions out there. But again, it probably took us orders of magnitude 10 man-years in order to get to that place. It wasn't easy. Yep.
Who are your customers? What industries? What are some interesting use cases?
Great question. Very happy about it. So the question is, who are our customers? So historically speaking, as I said, DigitalGlobe and most of the operators in our field usually had one big client. We still do. Most of our revenues today come from US government and other what we call international defense and intelligence organization. Because that's the most lucrative use case. They actually most often rent the control over the imaginary joystick, and they can actually take pictures themselves. But on the commercial side, as I said before, we were pretty much limited to players with big pockets. So historically speaking, most of the revenue for our commercial offering came from mapping. So whenever you open Google Maps and look at satellite, that's us. Go to Bing Maps, go to Apple Maps, you look at satellite, that's us. But there's so many of them. And right now we're trying to develop more use case with the help of GBDX. We actually got some really interesting use cases. And again, we're still kind of operating in the realm of big accounts or companies with big pockets. But one of the slides I've shown you before is the Geoscape product, which is essentially a product built by one of our partners for insurance industry. So essentially what they're doing is they're looking at a picture and they're doing, I have to put it in a very simple way, risk assessment for plots. Essentially they look at a picture of a house, they see, okay, there's actually a tree right next to the house and there's a pool. And they're starting to build, and they know what the height of the the heave and the roof and what the roof is made of, because we can actually do that analysis. And they say, okay, they can actually start assessing a property risk without sending someone over, which is the old way they're doing it. And that's a very interesting use case that was developed with our partner, as I said. It's in operation for the past year or so. And we're starting to see more and more of those use cases in the commercial environment now that we're actually able to substantially reduce the price to entry. So as kind of mentioned, the use case that I described before, the entry level buying the GBDX notebooks, that's $15,000. It's still pretty substantial. There's actually free tiers as well. It's still pretty substantial, but compare that to, you know, the $3 million use case that we talked about at the beginning. Okay, all of a sudden, those answers can actually be produced. Yep.
So, I mean, from what you described, it seems like, you know, the move to the cloud was a big shift in, you know, how you did things to how you were going to do things. It seemed like it was an inflection point where you made a decision to go to the cloud.
Yeah.
Going forward, looking forward, where do you think, you know, what do you think is going to be your biggest challenge, and where's the next inflection point, and what is going to motivate you? What sort of challenges are going to motivate you to make another big shift in how you do things today?
Okay, so I'll summarize the question. What do we foresee as the challenges going forward? I can actually give you a pretty substantial list of challenges that I see going forward. But I don't think we have the luxury of doing that at this point in time, because essentially the main effort for us right now, or kind of the main issue that we have to tackle, and I know this will not take weeks or months. We're talking about years worth of work here, is to re-educate an entire industry. This industry has been operating in a single way for, as I said, 20 or 40 or 50 years. We're teaching new tricks to a very old dog, not to say a dying dog, or probably in the grave already. But like it's hard. And all the history of like everyone who knows GIS went through university over the past 30 years, have been educated to do that. And the entire industry has operated on hordes of students that came out of university with that knowledge. So it's very hard. And it's also very limited, as I mentioned, because no one really had access to the imagery. So the hope that we're taking kind of a bottom-up, top-down approach. We're kind of preaching everyone about this solution, but we're also raising kind of the next gen of GIS folks to work with stuff like that. So everyone who goes through data science department these days, when they're kind of starting to see what data science looks in the GIS world, they're freaking out because it's kind of hard. But that's going to be the main challenge going forward. If you think about what GBDX is, it really is no different than what Salesforce did to CRM industry, with the only difference this happened 15 years ago. And we're still kind of in the early days of this shift in our industry, just because it's that hard. We're done? All right. Thanks everyone for coming. Thanks for your time. If you have any questions, I'm here.